Thanks, Johnny. Really good session there on the Autodesk Construction Cloud and some of the technology within there. So really interesting to see. And thank you, Mark, earlier on today with the new features inside of AutoCAD and recap format and Revit. Seems to be a good stable release this year with some really good productivity tools in there to help you save some time. So on to myself, really. So for those of you that don't know me, I'm Robin from Man & Machine. I'm the technical director here in the UK. And Nathan has asked me to put together a demonstration focusing on those of you transitioning from a 2D workflow into a 3D workflow. So perhaps you're currently using AutoCAD, LT, MicroStation, or a similar 2D design application, and you want to transition over to using something like Revit, whether that's Revit LT or full Revit, and a more collaborative or more digital design workflow. So that's exactly what I'm going to do. So for the next 45 minutes or so, maybe 50 minutes once we got to the end, I'm just going to take you through step by step, getting started in Revit and that transition from a 2D workflow into a 3D environment. I'm just getting a little bit of feedback, so I'm just going to mute my speakers there. So I'm using Revit 2022 for this, but the functionality that you're going to see is actually pretty relevant across most versions of Revit for the past few years. So generally speaking, when we're working inside of 3D, the workflows are not dissimilar to what you're already doing in a 2D world. So, you know, when we're drawing a wall inside of AutoCAD, for example, either we have a block that we use dynamic blocks with to come to life, or we're clicking a point, moving our mouse, clicking another point, and then doing some offset to add offset for plaster, offset for cavity, so on and so forth. So the process inside of something like Revit is very similar. So what we're going to be looking at is that similarity, but then what you get off the back of doing it inside of an application like Revit. So I'm inside of into the system now, and essentially what I have is 3/4 main areas of the interface. So firstly, on the top, I've got my toolbar, which is called the ribbon. The ribbon is intuitively split up into several different tabs for different areas of the application. I'm using full Revit today, so I've got the full suite of architecture, structure, and system-based tools. Obviously, Revit LT only has the architectural-based tools. But things are really easy to find, and actually it's set up very similarly with the same kind of icons that you're used to seeing inside of AutoCAD, for example. So you'll see that as we go throughout this demonstration. If I wanted to draw a piece of plumbing equipment, for example, I would go to the Systems tab because it's part of a system. I would go to the Plumbing and Piping panel, and then within that particular panel, I have all of my pipe work, placing of plumbing fixtures and sprinklers, so on and so forth. Whereas if I wanted to draw an architectural column, for instance, I would go to the Architecture tab, and then under Build, I have a column tool. So really intuitive, really easy to use. We have our main interface here, our real estate, where we do all of our drawing. You'll be pleased to know that the majority of the drawing and drafting that we do is 2D. We don't actually edit that much in the 3D interface, although we can. We typically use that for viewing, visualizing, collaborating, and checking things as we go. Typically, most of our drawing is done actually inside 2D workflows. On the left, we have a properties palette. You'll see me using that throughout the demonstration. That's where essentially everything inside of Revit, whether it's a view, an annotative object, a piece of furniture, a wall, a structural piece of equipment, all of those have properties and metadata. We're not going into those in a great deal of detail today, but everything that you have inside of Revit has intelligence. And again, you'll see that throughout the demonstration. Finally, to the lower left-hand side, you have your project browser. And that's probably the most important thing to flag during this, is we have a 3D model. So the vast difference between working in 2D to working in Revit, for example, is that we've got something that, you know, we can pick up and spin around and see and touch. Whereas in AutoCAD, we have a flat canvas where we have lots of different views of our building or of our design. In Revit, we physically have something that we can, you know, spin around, see and feel, so to speak. And the project browser is how we split that up into different subsections. So we have different floor plans. We might have several floor plans for each level to show standard layouts, FF&E, reflective ceiling plans, so on and so forth, depending on what outputs you then need on your sheets. So without further ado, we're going to start drawing. And the first thing I'm going to do is just jump into my elevations, which are represented by these elevation markers on my screen. I'll make a quick point that these have blank tags within them. You'll see them come to life a little bit later. And I'm just going to jump into my, my north elevation. You can see that this particular project from the template that I have defined has 2 levels that are already set up, namely level 0 and level 1. I'm just going to grab level 0 over here and just rename it to the ground floor and say that, yes, I would like to rename my view that's aligned to that. So whilst we have these as objects inside of Revit that I can use to place components on, they're actively parametrically linked to a view, meaning whatever you place within those views have a parametric constraint and link between these 2 floors, or whichever floors you align them to in your building. For this particular building, as the sun's shining, everyone's feeling rather summery. So I'm going to draw a simple villa, something that you might see in the med, so a squarish design, skinny but long, and we'll see how far we get to. But what we'll do is pretty much leave everything set up as default here, maybe a bit tall, 4 meters per level, but we'll stick with that. I'm just going to rename level 2 to my roof. I'm not going to go with any grids. We could come into a floor plan and start adding grids and then maybe use the 3D grids tool that Mark showed in his presentation earlier today. But again, I'm just kind of doing this as I go through this morning. So I'm not working to any specific structural grid. So I'm going to start on my ground floor. And on that ground floor view, I'm going to come and start my wall tool. And from my type selector over here at the top of my properties palette, I can choose the type of wall that I would like to draw. We have some preset ones inside of Revit naturally, but it's worth pointing out that as with everything in here, we can modify them. So whilst we're not doing this in a huge amount of detail today, I have the ability to take a ceiling, a wall, a floor, a slab, and come in and configure it either in section or in plan, so that I can configure, anything from the thickness of that render. Maybe I only want to have a 12 mil render on there. Maybe I want to have something thicker and go to a 32 mil render, for example. That will actively change not just the preview, but the actual build of that wall and everywhere that wall's used within the model. We can do the same thing in section to be able to control, sweeps and reveals or vertical detail to split a wall up, render into brick, into soldier banding, so on and so forth. Again, we just don't have time to go into the breadth of this today, but it's important to note that whatever you draw is controllable. So with my line tool selected, and this is where I said it is basically like drawing in 2D. If you look up here, I have pretty much the exact same icons that you'll be seeing inside of AutoCAD LT or vanilla full AutoCAD. We also have lines, arcs, circles, and squares. So I'm going to start with the line tool. I'm drawing unconnected 8 meters high. I'm just going to jump that up to 9 meters just so it extends beyond my roof layer. You'll see why later. Drawing the center line of the wall without an offset. And I'm just going to start by drawing a simple rectangle. So we'll go with about 10 meters. So click, type in your dimension, move your mouse in the direction that you want to go, and you have a fully formed and detailed wall. Unlike in a 2D application, for example, where you might only have a polyline or a standard line here, what Revit's doing in this particular case is it's creating a fully detailed and fully defined wall. Now, you can see that particular wall has certain line styles or line thicknesses. Typically in a 2D workflow, these would be controlled using your layers from the template. Revit has a certain setup or a similar setup, where you define line types, line styles, and different weights. But generally speaking, it's controlled by your scale. So what we have here is a view that will eventually be placed onto a sheet at a given scale. So a building won't fit onto a piece of A0. So what we're going to do is have a view scale at the bottom left of any view. That will scale everything on that view. If I jump this up to 1 to 500, you'll see everything gets bigger. It automatically scales everything, a bit like annotative scaling or annotation objects inside of AutoCAD. If I drop it down, everything becomes smaller. Text resizes so that it fits to your paper space size. I want 10 mil text. It will scale up and down in your view based on the size that you're going to print. We're going to stick with 1 to 100, but I'm actually going to turn on thin lines because when I'm drafting, I like to see the detail rather than the actual line style. So we've got our basic square. I'm going to go and select one of those walls, right click and create similar. But this time I'm going to turn off the allow join, because I want to create just really some detail extensions to this wall that aren't really going to be used for anything specific. So I'm just going to draw maybe 250mm out from each side, and these will literally just be really there to shade a bit of wind. There's going to be a little seating area at the front here, but they're not actually going to be used for anything specifically, so I won't join them to the rest of the building. From there, I'm going to go ahead and say that I want to put a floor down. Much like the wall tool, this is going to go ahead and create a floor, starting with a 2D workflow, but end up with a 3D output. So if I start my floor command, I again use my type selector to choose one of the floors or types of floor that I would like to draw. In this case, let's go with a ground bearing floor. Let's pick walls, and I'm just going to hover over one of the walls in my model and press the tab key. That will select a chain automatically. So again, this is where you're getting some intelligence inside of Revit. It knows that those walls are linked together, and it kind of appreciates or has the understanding that you're going to want to link them together like this. In this case, I've been lucky. It's automatically extending. You can see with this pink line here to the core of the wall. If this was an upper floor, like you'll see later, I could flip this to sit underneath the plasterboard if I wanted to, but let's stick with a core wall. Sorry, core floor in this case. And because we're a bit pushed for time, I'm going to just stop it there and hit tick. Whilst we're on the ground floor, I'm going to create another floor using the same type, and I'm going to create a separate area out the front here for seating, which I'm going to have as a separate floor. Not necessarily because that's how it will be constructed, but more because I want to control these with a different finish face from an architectural perspective. So I want them to have different floors. In this case, I'm going to say edit type, duplicate the type of floor, be very lazy and call it number 2. Not particularly friendly for digital construction, but for the purpose of today, it works quite well. And again, I'm going to pick just these 3 walls, join them up with a line, using all the standard tracking and snapping that you would be used to inside of something like AutoCAD, and place down a dimension to control that I want that to be 4.5 meters. Now, the dimensions are what we call temporary dimensions in AutoCAD, in Revit, in that they're only showing when we select what they are related to. Absolutely, we can place a permanent dimension on at any point just by selecting 2 edges, 2 faces, or 2 points. But typically, until you tell Revit that you want those dimensions on, they're hidden. We select what we want to move, and if I want this to be a 5-meter seating area, I select the object I want to move, and then I can just make a quick change to that dimension easily. Let's press the tick to place that down. We just need to make sure that we have a closed loop. That's my mistake for being too quick. So I'm just going to trim to corner, just to trim those 2 lines to a corner before we press the tick and complete. So what we've got so far is a very simple square design. And basically, we've drawn lines from an AutoCAD perspective or from a 2D perspective. But in the background, if I go and have a look at my elevation again, you can see that I've got a wall that starts on my ground floor, and that wall is going up 9 meters till it reaches its top, because I've told it to. If I told it to go to a level, it would be constrained to one of those individual levels. If we go and have a look at the 3D view over here, we can see that actually what we have is 3D walls and 3D floors that we can go and select, see, touch, spin around, and navigate to within my model. So already, by doing the same kind of things I'd be doing inside of AutoCAD, we're getting more. We're getting a lot more control. Before we do anything more on the ground floor, I'm going to jump up to the first floor of this building and just do the same thing again. I'm going to add a few floors. So let's go to Architecture tab. Let's go to Floor. And the inside of this building, we're going to say has got a timber floor. Once again, select the walls, hover over one and hit tab. And I'm going to place a single floor again, just to make this nice and straightforward today. But I will flip so it only sits underneath the plasterboard and doesn't actually go into the core of the wall. Again, for the purpose of this, more than happy with that placement. So I'm going to press the tick. I'm going to say, yes, I would like Revit to attach the floor to the walls. What's interesting there is, again, some of the intelligence that you're getting from doing this. So if we just strike a section through the wall here and just go and have a look at that section, turn on the fine level of detail and zoom in, what you can see that Revit's done as part of creating that floor is it's done one of two things. Firstly, where the plasterboard comes down, it's running the plasterboard down to the core or the structure of the floor. In this case, it's a timber floor, so it's down to the timber. Okay, so it's cut the finish of the floor so that it butts up to the plasterboard. Likewise, it's also taken the plasterboard out when it comes to the structure of the floor. The same would be true on the base level if this extended down into a foundation like you'd have in reality. So, you know, Revit's saving you a lot of time in doing those details for you automatically, which is really, really beneficial as you go through. Let's just take that section out because we don't need it for now. And let's go and create another floor. This time I'm going to use a concrete course floor for the balcony at the top. I'm going to select walls and select these three, followed by select line, pick the same line that I had on the lower level, but maybe just drag it back ever so slightly. I only want that top balcony to be about 3 meters. Again, tidying that up using standard tools like trim to corner. I'm just going to create one enclosed region for this particular balcony and press the tick. Again, it's going to say, would you like to connect things? Yes, I do. Go and have a look in 3D. And now I have my upper and lower floors on my building. Let's just jump back down to the ground floor and start adding some details. So I want this to be quite modern and look quite nice from the front. The way I'm going to access this building is from the front. So there's going to be some steps up here. And maybe I want some nice full height, full length windows on the front of this. So I'm going to use curtain walling for that inside of Revit. So that's drawn by, again, creating a wall. And then from my wall selector, I'm going to scroll all the way down and I have some curtain wall types. Now, a curtain wall is pattern based. So whilst I'm using it for glazing here, you can use it for paneling around the outside of the building, or typically anything that patterns across with panels and structure. So in this case, this is going to create structure using grid lines, and then it'll fill the free areas with a panel. And all of that is controlled by a family or families, which we'll talk about shortly. Those families are essentially like blocks. So it's going to fit them with one type or several types of block. Now for this morning, I'm just going to have a pretty empty wall. So I'm going to start with a blank wall. I'm going to make sure that that wall automatically embeds into my building because I want it to automatically cut the wall. And I want to go on the ground floor, but have a bit of a gap. So there is a step up. So some brick or some render in this case before it actually gets to the framework. So I don't know, let's go with 250. So that'll create a parametric constraint from the lower level ground floor. 250 up is where it will be locked and start drawing. I want it to be unconnected again, but I want it to be flush with my ceiling. So let's say that we want to go up to a height of 400. Apply. I can then start drawing. So I'm just going to trace over my wall and roughly draw that curtain panel in. If I select that, again, I've got the ability to control this. So let's say that we want 250 from each edge. Now, again, with Revit, you select something before you make a dimension change, but in some cases that can throw you out because, you know, if I went over here, selected the wall and changed this to 250, it's going to break the 250 on the other side. So you need to remember that Revit has this parametric intelligence. And if I want that dimension to stay at 250, I make it a permanent dimension. I select that dimension and I lock it. That now means that if I come over and select this dimension and set it to 250, we have a lock of 250 both sides. This is a little bit different to working in AutoCAD. It's more controlled, it's more intelligent. Therefore, it maybe takes a little bit more getting your head around or a bit more understanding initially. But that dimension is now there. I could hide it. In this case, I'm actually going to delete it. I don't need it. And actually, I don't need that constraint there in the background. So this will now move freely again. But we've got the ability to control these parametric, dimensional or geometrical constraints if we need to. I want the exact same setup at the top. So I'm going to select this wall and I eventually want to copy it and paste it all the way up. But before I do so, I might as well get all the panels and everything in it that I want before I push it up to an upper level, because I literally want them to be identical. So let's come and have a look at this elevation from the south. And here I have my curtain panel or my curtain wall. I'm going to say that I want to place a curtain grid. This is literally going to draw reference lines across this curtain wall that I've just drawn in. And those reference lines will become center lines for my structure. In this case, I'm going to add some mullions, some aluminium mullions, and they're going to use as the center line to drive those families. And I want to split this into, I don't know, maybe 6. So we're going to have 1, 2, 3, 4, 5 lines and 6 panels. From there, I want them to be equally spaced. So I'm going to go and grab my dimension tool, either from my annotate tab or just from the quick launch toolbar at the top here. And I'm just going to go in one strike, so left, and then click on all of the individual grid lines to bring up a chain dimension, place them down and press EQ. This will keep these equal, okay? Now that is something that I do want to keep in, so I'm going to grab this dimension and I'm going to hide it, hide in view elements, just to make it vanish from my display. It's still there, it's hidden in the background. So if I ever want to bring it back on or use it, I can just unhide it, for example. But that's a constraint that I want to keep on in this model. Let's also add a curtain grid around about 400 from the top. I want a small window at the top, followed by full length windows here, which I think will look quite nice. From there, I'm going to go ahead and select mullion, choose all grid lines, and maybe choose that I want to add, I don't know, a 30mm square mullion against all grid lines on this window. You can see straight away that that adds detail and puts all of those objects in as 3D structure or mullions against my glass panels on my door, or sorry, not my door, my curtain wall there. If I go back to my ground floor and be quite lazy in that I'm now going to select all of those components, I'm going to use a standard copy to the clipboard, and then I'm going to choose that I want to paste them from my modify toolbar aligned to selected levels and put them onto the first floor. What that will do is it will take anything that I had selected at that lower level and it will paste it up to that top floor. So because I wanted the exact same configuration, I've got the exact same configuration up the top. Now I want to have some access in here, so I want a door. I've got one in my default family that comes pre-installed with Revit, so I don't need to use the tools that Mark used earlier to load families off the internet. I'm just going to standard load a family off my hard drive. Go to my metric library, into UK, go into my curtain wall panels, and I've got a few glass doors in here, which again, for the purpose of this demonstration today, will be absolutely fine. Let's grab a nice glass door without a frame and open it into my project. From there, I can say that I want my entry on my ground floor to be this one here. So I'm going to hover roughly over where the panel is and just cycle with tab on my keyboard until it gives me that panel. It highlights it. If I select it, it goes slightly transparent to show that I've got it selected. And I can change it from a standard glazed panel to a glass panel door. If I wanted to flip that door, either with flipping the hinge or flipping the finished face of the door, I can press spacebar to do so. I want it opening inwards, and I want it opening to the left as we look at it from the front. Sorry, the right as we look at it from the front. Getting confused because on the camera, my right's my left as it's flipped, but hey ho. So that's absolutely fine. I'm going to do exactly the same thing at the top. So I should have really done this before I copied, but let's go and grab it and change to the same configuration as well. Let's place a roof on. So we're starting to get something that looks about right. So let's jump up to our roof level. We're just going to have a flat roof on this particular design. We're going for the med, right? So it's never going to rain, apart from probably when we all eventually manage to go on holiday. It'll end up being some tropical storm. But hey ho, let's go into the architectural tab, add a roof. Again, from our type selector, I've not really got anything in here that's that relevant, to be honest. So I'm just going to use a flat felt roof for the purpose of this. It'll be fine. Pick walls. Add a little overhang, as I want to have a small overhang around the outside of my building, about 250mm. Maybe that's a little bit high. Let's go 175. I don't want any slopes, so I untick define slopes. And again, I'm just going to hover over my walls and select them. I want this one to extend a little bit over the balcony, but not too much. So I'm just going to align it there with these walls that come up from the ground floor. From there, I want it to be 250 or 200, 175, whatever I set it below that. So I'm going to choose move, grab that line, move downwards with my mouse and type in 175. So again, much like you would in AutoCAD, to be completely honest for you, the process here, as you've seen, is not dissimilar. I've drawn walls as click, move, click in 2D. I've drawn a curtain panel with the same way. I've then gone into an elevation and basically told it where I want the grids and spaced them the way that I wanted them. The only thing that I've really done in a 3D workflow is the selection of that panel to change it to a door rather than a standard piece of glass. So, you know, the process here is not too dissimilar to what you'll be used to. The great thing I like about this is as you get more workflow is we can start leveraging Revit. So on my ground floor, for example, if I just say WT, window tile, or indeed I could go to my view tab and tile my windows. I've got the ability to see my objects using multiple views. That might be a plan versus a section. That might be an elevation versus a 3D view, or even all four at the same time. These can be separated onto a separate screen, should you want to. They can be floating windows, however you see fit. And what that allows you to do is select elements within 2D and have them highlighted within 3D. We can make modifications to things in 2D and see the direct correlation to those in 3D, should you want to. So you instantly get this visual tool as a designer where you can see what effects your decisions have on the actual look and feel or style of that building. I'm just going to revert back to a single screen and jump to the ground floor. Looks like I've accidentally dragged something off, so I'm just going to use my align tool, AL on the keyboard, or the align button that you're used to seeing inside of AutoCAD, and I'm going to make an alignment of these walls. It looked like they dropped off there, which is a bit frustrating, but never mind. So building wise, the outside of this building, you know, I'm pretty happy with, to be honest. I think that's absolutely fine. I don't have any concerns with the actual size or shape of this. It looks like my align was the wrong way around. So let's just do an undo, make sure we align it the right way. There we go. And from there, I'm going to start looking at the interior of this design. And the process is exactly the same. I go to my architecture tab, and the first thing I'm going to do is draw some walls. But from my wall tool, I'm going to choose a type of wall that aligns to an internal partition. So maybe a 75mm stud with 12mm partition or plasterboard, sorry, either side. I'm going to have quite a small villa here. It's not a huge thing. So I want a nice big open plan entertaining area. So living, dining, maybe a small shower room so that you can come in from the beach and jump in the shower room, and a small kitchenette so you can make any drinks or food that you might want. So using standard AutoCAD functionality, actually, I'm going to trace down here about 2.5 meters, click, and go fully left to right. By drawing that that wall in, we basically get something that's wrong because I forgot to turn back on disallow joins. 2 seconds. Make sure that you return on join status if you've turned it off, otherwise it doesn't show things very well. Let's go 2.5 meters, completely left to right. And again, just small things. Think about that join. If you were doing that inside of CAD or manually, you'd have to trim, extend and cut back all of this geometry to get that to work. In here, it's just doing it for us. So we're going to place that horizontal wall. We're going to create another one, which is going to be about 2 meter, like so. So we've got a fair size kitchen and a fair size shower room over here. With those, I'm going to choose to add some wooden doors. I'm not a fan of the ones in my template by default. So again, I'm going to use my standard downloaded library, not what Mark showed earlier. I could easily go onto the cloud and download them from there. Pick up internal doors. There's a lot of commercial based ones in here. I'm going to go and pick a more internal looking door like that one. Open it up, choose an appropriate size. We're going to go for the larger door with this example here. And we're going to place a door there, hit spacebar to flip it, and another door there, giving me an entry point. Maybe this door's a bit big for the shower room. We don't need this to be accessible for this particular design, so we could make that one a little bit smaller, for example, if we wanted to, just to give a bit more space in this area of the shower room. Again, they can be selected and tweaked with regards to their position, just like you would inside of any other 2D, 3D application. No problems at all. Happy with the space that we've got here. Maybe this is a little bit small. So again, all of this can be changed on the fly. So I want an internal dimension of that kitchen no less than 4.5 meters. And these witness lines, we can move those anywhere. So I can control that that dimension is picked up, external face to external face if you want to. But in this case, finish to finish, I could change that to say, well, actually make that 4.5 meters. Revit will warn you if it has any clashes or interference issues, which you can then come and pick up and fix on the fly straight away, should you need to. So again, it's giving you more feedback. It's giving you more visual as you go through. We need some sort of staircase to get up to the top level. But before we do so, I'm going to grab these walls. I'm going to copy them and I'm going to paste them aligned to my first floor. So again, I'm going to be a bit lazy. I'll move them once I get up there. But for the purpose of this, I'm going to copy and paste them up because I want the same kind of design. I'm going to go onto my stair tool, choose to draw a run, and I want that run to be 1 meter wide. Now my stairs have pretty typical calculations in there. So it's going to start at a point and end at a point, which typically are linked to one of those levels that you've drawn earlier on or that you've created earlier on. I'm just going to say that I don't want 24 steps. It's going to be quite narrow steps. So I want maybe 15, 16 different risers on here. Let's go for 16 risers. And based on that, it will calculate the riser height and the tread depth. Now, all of that is based on some calculation rules against that particular stair. So we can come in there and see how it's calculated those and chop them and change them as necessary. But in this case, I'm happy with that. It gave me a bit of a warning about the height of the risers, but I'm not overly concerned. And what I'm going to do is draw the exterior support right, because I want to trace along this partition and this partition. And so just by drawing essentially, again, line work inside of a 2D application, I'm going to click once roughly where I want my staircase to start, which is approximately halfway along this wall. So I can click. And when I start drawing, you'll notice it previews that stair generation. So this is the complete length of the stair to get to where I wanted. I'm already a bit pushed for space in the kitchen, so I don't want to have any area where I can't have some full length cupboards. Nothing worse than having a cupboard or a kitchen that hasn't got the right cupboard space. So I want to go up a handful of steps and then turn 90 degrees and then go up the rest. So we want a typical L winder. So let's go up 5 risers, click my mouse, and then I'm going to leave a gap, and I'm going to make sure that I leave enough gap for the stairs to straighten up, turn the corner, the handrail turn the corner before it continues up the staircase. So it's probably a bit much in this case, but again, I'm going to draw from here now and continue up. And you can see that I now get the rest of the risers, and I can go and place them all in like so. If I press the tick, and then maybe put a selection around my lower floor geometry and say from my modify tab that I want to place a selection box, BX is the keyboard shortcut, it places a section box around my selection. And what we can see here is actually it's done a pretty good job of placing that. It hasn't cut any slabs. We're going to do that in a second, but we've got something that looks okay. Clearly, we need to move the positions of our walls and doors upstairs, but actually I'm quite happy based on the plan that I've got for that upstairs space. Let's go ahead and shoot back down to my ground floor. Let's go to my reflected ceiling plan on my ground floor. And let's say that I want to now add some ceilings to these enclosed spaces. So I'm going to say add a ceiling automatically and click 3 times, once in each enclosed region. That will create a ceiling in each region based on the height. I think I accidentally left them on 2600. So I'm going to select one of the ceilings, right click and say select all instances in the entire project and drop them down to 2400 rather than 26. I'm then going to go back to my ground floor and I'm going to say that I want to define rooms within those enclosed areas so that I can start using this intelligence and this parametric data later. This will allow me to come in and start doing schedules to say, show me where that door is, show me where this object is, show me where I've got these pieces of furniture, show me what finish I have on the walls in the lounge, for example. And for the purpose of this, I'm not going to do anything overly specific because we're not spoilt for time today, but I'm just going to put a few things in there and say that I want to have the names. You'll notice they're numbered automatically. That numbering will start and continue from wherever you are. And what we're going to do is just turn off the square footage because we don't want that. We don't want the imperial measurements here in the UK. So we've got our metric rooms there. So ground floor wise, pretty happy with that. Let's just jump up to the first floor and do a couple of other bits of detail to finish this off. And then we'll move forward a few steps and start looking at the outputs from this and how much we can benefit from those. So the walls that I put up on that first floor, they need to be moved. You know, the top of the stairs finishes here. That's not the first floor, that's the reflected ceiling plan. So the stairs finish here and there's not enough room to maneuver. So what I'm going to do is actually delete this out, trim back this wall, and I'm going to pull this forward so that we can come up the stairs and we've got a few different choices. So for the purpose of this, I'm going to say create another internal partition. I want that to align to the staircase, but again, I'm just going to draw it eyeballing for now, and I want the same thing on the other side. I'm going to create this particular door, and I'm going to create one here to get into a bedroom. I'm going to create one here to get into a bedroom, and then I'm going to move this particular one here to place it just there. If I just do some alignments and align using my staircase here. So let's grab the staircase and align the wall to it. Let's move this downwards a little bit so we don't have any conflicts. Let's then pick another alignment and pick again the staircase and this partition so everything lines up. And from there, we're just going to grab this wall and drag it on. So we come up the staircase, we have a secondary guest suite, we have a single bathroom, not fussed about en suites here, and a nice large master bedroom. Again, we can come in here and start adding ceilings. So I can go to my first floor, grab the ceiling tool and place ceilings in any enclosed space. And we could also come in to that first floor plan and we could place down rooms within there, which again are automatically numbered and named appropriately for you. I'm not going to rename all of these as we're a bit pushed for time today, but you get the general idea. You get what we have here and everything's starting to take shape and come together quite nicely. Now, what's really good about this is I'm just going to start choosing some slightly different sizes and shapes of doors, just so that we've got some variation in the model. Because one of the big parts about using a 2D workflow rather than a 3D workflow, rather than a 2D workflow, is the intelligence that it gives you. So in Revit, it knows a door is a door. It knows a window is a window. So if I come in and place a small window, which is going to be tinted or frosted in my shower room, and place a large window that's going to be nice and open above my sink so I can look out in the kitchen, it will know that they're windows. If I go up to my first floor and do the same thing, so let's go and grab another window. Again, nice couple of large ones here in the guest bedroom, and maybe a small one in the bathroom. Revit will know. Let's just choose something that's not been used before, that one. Revit will know that they're windows. So that gives me the ability to tag things and to identify things quicker than we've done before. For example, in this particular model, if we just turn this, this section box off, whilst I've very quickly put something together that's looking okay, it's just a model so far. It doesn't really have any intelligence, and we're not seeing, apart from the model, the benefits of having that intelligence there. So what I want to do within this model, before maybe I went on and started adding some detail of some railings around here, maybe extending the roof out and adding some more detail columns, is I want to look at how this, how we can pull information from here now. And I'm going to do that in two ways. So the first thing I'm going to do, which isn't that relevant for this particular design, but there are a lot of commercial designers out there and commercial architects. So I'm going to go onto my ground floor and I'm going to imagine that I want to start creating some views that will eventually go onto my sheets. So I'm going to duplicate my ground floor floor plan, and I'm just going to rename it to maybe ground floor FF&E. I'm going to do the same on my first floor. So I'm going to grab it, I'm going to duplicate it, and I'm going to say first floor FF&E. So very quickly, I've got duplicates. They could contain or not contain detail as you see fit. But in this case, it's literally just a base view. So on my ground floor FF&E, the rooms are there, but they're not tagged, for example, whereas on my ground floor, they are tagged. I've probably done that all the way around. I kind of wanted it the other way, but generally speaking, on this this finishes and furniture view, I could start placing components that I only have visible within this view, and that might be controlled by a view template in your Revit template file. But for example, just to start putting some bits in here, if we say insert, load Autodesk Family to use the functionality new in 2022 that Mark demonstrated earlier, and we'll just use some furniture. And we're going to grab this this Kallax style unit here and load it in. And we're just going to place one of those within our model that's just sat against one of the walls in the lounge. I'm going to do the same thing. So insert, load family off the internet, and maybe we're going to go and grab a dining chair, not particularly aesthetically pleasing dining chair, but it's a dining chair nonetheless. And we'll also grab a sofa. I'm not filling this up today because, quite frankly, we don't need to for the purpose that we've got. Time doesn't really allow. So I'm just going to add a sofa just here, and I'm going to add a couple of those dining chairs around like so. So using this this FF&E floor plan, I can see those components. If I didn't want them to be displayed on my ground floor, I can literally say hide in view category. I now have a ground floor view that's literally just going to be used, for example, for construction dimensions or the actual information that I might want or need to design and build this. Whereas my ground floor FF&E, I want to show the internals. I want to show things like the internal dimensions. I want to show things like the floor finishes. I want to show the rooms and tag those appropriately using the right tags. I also maybe want to go in and tag the doors so that they can be identified on a door schedule. So let's go in and say that I want to tag doors as well. And again, should have said tag all automatically. That would have been much nicer to show. Let's just do an undo. Let's tag my room like so. There we go. And then we'll say annotate. Tag all, and I'm just going to say go and tag all of my doors, apply. This one's not picked up a mark because of what it is, so let's go and put a mark in there. 3, maybe it's using type mark. I've got some upstairs. 1, 2, 3, 4, 5, 6, 7. There we go. So I've got my tags on there for my doors, again, placed automatically. And what I'm going to do against this particular FF&E, just to start wrapping this up, is I'm going to say that I want this view to be colored based on its rooms. So let's go in and add in, with nothing selected, I can go and find color scheme in my view properties, choose to color this by rooms, maybe by the name of the room, and press apply and OK. That will color the rooms uniquely based on their color, or based on the name or their number. Or if you're MEP, that might be coloring them based on the amount of light in that room, so that you can have areas with low level light as red and areas with too much light as a green color, for example. So you can start to identify exactly what's going on. Maybe we'll add some room name in there and just put another internal dimension on. Let's just use the kitchen, as it's a slightly bit bigger than that utility room there, and just add those on like so. Once I've got these, I'm just going to go to my view tab, and I'm going to start a schedule. So the great benefit of moving to 3D is that information you can pull, not just the speed in which I can say I want another view into that ground floor, but showing different things. I can start pulling more information. So I can say, go and give me a door schedule on this particular model. And on that door schedule, I want to get the family name. I want to get the type of component to get the size. I want the cost. And these are all properties or metadata or attributes that are linked into my different families or blocks, to use 2D terminology. I can place these properties into a schedule. Just hit OK and it will give me a flat list. Not that important at this stage, but what I can use this for, if I just close a couple of these down, use my ground floor view alongside my door schedule, I can say, okay, well, where's this door in my schedule? And it will start highlighting the doors based on where they are in the model. So this particular door I know is a 60-minute fire rating. I can apply that to every time that type of door was used, because I have 2 more of those on the upper floor. I'm just going to do the same thing for the other ones and just do a mismatch of 30 and 60 just for the purpose of this, just so you can see some different values. And then what we're going to do is give those a cost. So I'm going to be very unrealistic and say those ones are £100, those ones are £200, and those are £50. From there, I'm just going to go full screen back into my schedule and just tweak it slightly so that it's adding everything up. So let's go into my fields and add count in here, because we don't need to see each individual listing. And let's sort these first by their family, then by their type, then by their fire rating, then by their width, and hit do not itemize every instance. That'll then give us unique counts of each one. So I've got 3 of this type of door, 1 of this type of door, and we can do that with anything. We can do room schedules to get our finishes. We can look at what doors connect what rooms, and then interrogate the fire rating between those particular areas if one's meant to be a safe area, for example. So the ability that you have on here is huge. And then once you've got that model, we can start putting together sheets. Sheets in Revit are probably even easier than Paperspace in AutoCAD, because what we have, if I just take this one off, is the ability to work with this really, really quickly. So on here, we have a ground floor plan. That ground floor plan is showing elevation markers. And for the purpose of this, we're also going to put a section view. And I'm going to place a section view that's showing some internals up to this door, but mainly, the detail of this wall. Maybe we had a window in there that we want to focus on the detail for example. Again, just making a point to these tags. If I go into my sheets and add a sheet using a title block, A1 for the purpose of this, what I can do on that sheet is say, well, I want this to be my ground floor layout. So I'm going to grab my ground floor view. I'm going to place it down here. I'm going to go and find my section view, and I'm going to place it down alongside just here. And I'm also going to go and grab my elevation. Let's just use the south elevation for the purpose of this. And I'm going to place that just here. I'm not too fussed about the sizes for the purpose of today. Again, these are going on at 1 to 100 because that's the scale that those views are at. But what you can see is you get exactly what you have inside of those views. You notice that on sheet A101, view 2 is section 1. If I jump back to my ground floor, it's automatically updated this tag. That alone, 2D workflow, is such a painful process to make sure you go and update all of those so that they're linked correctly. It just does it automatically in here, which is great. It's often overlooked inside of Revit, but if you are moving from 2D, that functionality is fantastic. I'm just going to go into that section very quickly. Just change the scaling down to 1 to 20, fine level of detail, and just crop it down so it's only showing me up to the ceiling. I'm going to hide the elevation marker because I don't want that to be shown. And if we jump back to our sheet, we can see that everything on that section doesn't update, which is interesting. Over there. Okay. The joy of live demos, as one of my good friends would say, the demo ghost strikes again. I'm sure you're watching. But there we go. It's updated that view based on that output, which is fantastic. So everything that we're doing on the views is natively getting transitioned across the sheets. So we just carry on like that. If we wanted to do another sheet with those FF&E finishes on there, we can add another sheet. We can drag and drop not only our ground floor FF&E, we could also drag and drop in our door schedule that we created next to that as well, like so. So everything that we place down, we can get quickly updated and everything is live. So if I go and place another one of these doors int 6 on my ground floor, architecture, doors, we had 3, we're going to place, forgot what size it was, I'll place another 810. let's place it randomly in that external wall. Not that we'd have that. We can go in and see that that's now updated to 4 rather than 3. So everything's live. Everything starts updating and doing what it needs to do, which is fantastic. A little bit Blue Peter style, as I'm a bit pushed for time. I've overrun by 5 minutes already. Sorry, Nathan. I'm just going to open up one that I created earlier that just kind of shows you the level that you can get to without too much additional stuff. And this particular model, it's the same design, but this one's focusing on making it look nice. So inside of Revit, I've just whacked the view quality to realistic so that it looks a little bit nicer within my view. Those views you can place down on your sheets, which is great. So if I go and have a look at my sheets in this case, we can see that we can place 3D views down nicely. But the reason I brought up this second one is to show you how using 3D and using something like Revit really enables you, let's close that one in the background, really enables you to drive better outputs. Not necessarily from a quality perspective, because the kind of drawings you guys are putting out in MicroStation, in AutoCAD and 2D, they're fantastic and they look lovely. But that quality you can reach inside of 3D using detail elements and detail lines in Revit. And you have the ability, well, because you have a 3D model, to leverage things like Enscape. Enscape is a third-party bolt-on. You've also got Twinmotion, which is another third-party bolt-on, sits outside of Revit, where you can literally come in and start visualizing your designs live whilst you're doing them. This could sit on another screen and update whilst you're designing. So, for example, these are just default Revit grass and water materials, by the way, that it's automatically animating in the wind and doing what it needs to do. Everything that I've got on here is an auto update. So if I just come and stand here, I'm currently looking at my standard 3D view. So inside of where's my view button? View management. I'm looking at my standard 3D view here. If I just minimize, go back to my standard 3D view in Revit, you can see that this is what it's looking at. If I change this view, or indeed change the model in any way, even on a floor plan, everything will update. So I'm going to be quite lazy. On my first floor, I've got this configuration of seating. I'm going to, once again, clipboard copy, paste aligned to the ground floor, my favorite tool from today. That's updated the Revit model naturally so that geometry now exists. Likewise, it could have been a delete or a modification of geometry. But if I jump straight back into my renderer, it's instantly put those assets in there. By leveraging things like Enscape, we can take our customer outputs or even our customer engagement meetings to the next level, where actually we can have more conversations with the client about how they want something to look, how they want something to feel. When I'm sat in my luxury villa in the Med, what am I going to look at when I wake up in the morning and look out the window? I'd love to have a dormer there, for example, or a skylight to see what's going on in the sky. Make sure it's still sunny and not raining. But all of this functionality becomes available by having that 3D model. It's not just the fact that your outputs are quicker to generate typically because you're drawing what would be a line and it's doing a wall. You're striking what would be a line and it's actually putting a live section through the model. You can also render. You can also instantly render. You can leverage things like Enscape or the cloud-based families that Mark used earlier to fill our product or our design full of, in some cases, very high quality assets, which can be then used to really bring a scene to life and really show a client what you're working on and what's happening. And for anyone that is using 2D, just to finish this up, if I go into a video editor and say that I wanted to be able to share with a client what their design is going to look like in 3D, and really visualize that, we can literally press a few clicks, hit the play button, and we have a video, which at a single click of a button could be exported out very quickly into an MP4, uploaded onto the internet or whatever it might be. We've really scraped the surface of Revit today, but again, we were keen to revisit something that we've done before and show you how using something like Revit, the transition from 2D to 3D isn't as painful as some people think, but the benefits that you can get from it are absolutely fantastic. So I think from my perspective, that's kind of all I wanted to show. So thank you very much for listening. I'm going to hand over to Nathan now, who's just going to wrap us up and finish off the session. Thank you for your time.